We're getting ready to solve a different kind of trigonometric equation. This kind of trigonometric equation looks like a quadratic equation that we used to study back in intermediate algebra. I say that because as I look here, it's the first time I've seen a squared symbol in a trigonometric equation. So since this carries me back to intermediate algebra, I'm going to set up a parallel example to this one using just x's wherever I see signs. So over here on the right hand side, I'm going to say, let's pretend this is 2x squared minus 3x plus 1 equals 0. And let's pretend I was back here in intermediate algebra class and I needed to solve this quadratic equation. One of the methods we employed to solve trigonometric equations or to solve quadratic equations back in intermediate algebra was to use factoring. And I'm going to attempt to factor this trinomial into 2 terms times 2 terms. After playing around with the various terms here, I see that the correct factors are 2x minus 1 times x minus 1. If I were to FOIL these 2 terms times these 2 terms, I would get the trinomial on the upper line. Now, if either one of these factors is equal to 0, I will get 0 for an answer. To see when either one of those factors is equal to 0, I say when is x minus 1 equal to 0? And it is when x is equal to the number 1. This factor will be equal to 0. I say when is 2x minus 1 equal to 0? And solving it, as I would a simple linear equation, I get when x is equal to 1/2, this factor will be equal to 0. If this were an intermediate algebra class, I'd be done, and these 2 numbers would be my answers, the numbers that I could put back into my equation, replace them with x, with those numbers, and I would get the correct solution, which is 0. Now, to mimic off of this intermediate algebra problem, I'm going to come over here and I'm going to say, okay, then the same thing must be true here. 2 times the sine of x minus 1 times the sine of x minus 1. If I were to FOIL that, I would get that trinomial back again on the upper line. And similar to the way I solved this equation back in intermediate algebra, I'm going to take each factor and I'm going to set it equal to 0, and I'm going to solve it for the sine of x. 2 sine x minus 1 equals 0. 2 times the sine of x is equal to 1, and the sine of x is equal to 1/2. Now over here in intermediate algebra class, I was done. Unfortunately, that isn't the case here in trigonometry. In trigonometry, I have to go back over here, and my job is to figure out what angle I could put in place of x that would produce this ratio that I see on the right-hand side of my equation. And I'm thinking about what those angles would be between 0 and 2 pi, since that is what I was asked in my original question, to produce the answers between 0 and 2 pi. And I'm thinking about that, and I say, you know, knowing from my charts that the only angle that produces the ratio 1 between 0 and 2 pi is going to be pi over 2. Okay, that's it. Now I'm over here and I'm looking at this and I'm saying, what angle would produce the ratio positive 1/2 for sine? And here we go again. If we're talking about sine, sine is positive in quadrant 1, sine produces positive ratios in quadrant 2. So my angle would have to be an angle in quadrant 1 or an angle in quadrant 2. The angle in quadrant 1 that produces a positive ratio 1/2 is 30 degrees, or pi over 6. Now, since this is pi, and this angle is less than pi units big, I subtract pi over 6 from pi, and I get 5 pi over 6. So now I say there are 3 angles between 0 and 2 pi that would make this a true statement, and the 3 angles are pi over 6, 5 pi over 6, and pi over 2. Those are the three answers between 0 and 2 pi for this particular problem. And we're done.